Welcome to the Sleepy Physicist. Tonight, you and I will drift gently through space-time, not to be pulled in, but to understand. We'll follow collapsing stars, listen for Hawking's quiet radiation, and ask the question physicists still whisper: can black holes ever give something back? This is not science fiction. This is sleep through science. This is real. This is gentle. This is the Sleepy Physicist. You close your eyes, and the world begins to widen. Above you, no roof, no sky, just a sea of stars, scattered like dust across a midnight field. Some of them are so far away their light has traveled for billions of years just to find you. You lie there, still, quiet, held in the dark like a thought not yet spoken. You're floating now, the weight of your body slowly loosening, the gravity of Earth fading behind you like the hush after a song. Higher, softer, deeper, you drift, past the upper clouds, past the hum of satellites, into the gentle hush of space. There is no sound here, not really. No breeze, no rustle, only the soft shimmer of distance. Light moves, but it does not speak in this stillness. Something ancient waits, somewhere in the quiet, perhaps in the direction of Sagittarius, or far beyond the reach of our tiny solar system. A black hole rests, not like a monster, not like a mouth, but like a breath being held for a very long time. This chapter doesn't begin with violence. It begins with weight. Imagine this: a star is born. It blazes in the cradle of a galaxy, spinning, fusing, glowing with fierce devotion. Over millions and millions of years, it shines, casting light into the void, pulling planets into its warmth, anchoring entire solar systems. Its life is long, luminous, and generous, but even stars run out of fuel. One day, after a lifetime of light, a heavy star begins to change. It cannot hold itself up anymore. It wobbles inward, slowly at first. Then suddenly, the outer layers collapse. The heart caves in. Pressure mounts beyond what words can carry, and in that moment, a black hole is born. But you are not witnessing destruction. You are witnessing transformation. You see, a black hole isn't a hole at all. It's more like a place in space where matter has become so dense, so tightly packed, that gravity becomes irresistible. Everything nearby, dust, gas, light, feels its pull, not like a violent snatch, but like a slow, inevitable sigh. You drift near, but you're safe. You're not close enough to be caught, just near enough to sense its presence, like the hush that falls before snow, or the stillness in the air before a storm, not threatening, just waiting. There's no edge to see, no border to touch. Instead, you notice something subtle. Light that should move straight begins to bend. Stars behind the black hole warp and curve, as though you're looking through melted glass. This bending is called gravitational lensing. The black hole is so heavy, it curves space itself. You float closer, imagining space like a soft fabric stretched taut. A black hole presses into that fabric, making a deep well. Not a tear, not a break, just a deep, invisible valley. You wouldn't fall all at once. You'd spiral slowly, like a leaf turning in a quiet wind. This gentle gravity, this stillness in the stars, is not absence, but presence. And even in this silence, the universe keeps moving. Galaxies spin, nebulae drift. Light continues its endless journey. But black holes remain the quiet ones, the keepers of deep time. They do not shine, they do not speak. and yet they shape the world around them in ways we're only beginning to understand. As you watch, you begin to wonder, what does it mean for something to fall forever? Inside a black hole, even light cannot escape. Not because it is trapped by a wall, but because space itself has tilted downward, like a slope too steep for anything to climb. Here, near its edge, what scientists call the event horizon, time begins to behave differently. If someone watched you from far away, they'd see you slow down. To them, your fall would never finish. You'd seem frozen at the edge, suspended in twilight. But from your perspective, time would feel normal. You'd keep falling. You wouldn't notice the stretch. The clock in your chest would keep beating. It is one of the strangest, quietest truths in physics that time is not fixed. It stretches and curls, depending on where you are and how fast you move, and how strong gravity becomes. And near a black hole, gravity is everything, but there is more comfort than fear here. You are not falling, you are observing. Your mind drifts calmly between understanding and awe. This black hole, born from the ashes of a star, now rests quietly, invisible but influential. A sculptor in the dark. You may ask, is this the end of the story? Is this where matter goes to disappear? But the universe rarely writes such simple endings. For centuries, we believed black holes only swallowed, that once something passed the event horizon, it was lost forever. Information, atoms, light, all erased. But now that belief has begun to shift. A soft idea is beginning to flicker at the edge of science. A glow, faint as a firefly on a moonless night. Could black holes release? Could they, in some quiet way, return what they've taken? The thought dances at the edge of your mind, delicate and unresolved. Some scientists think black holes may not be perfect prisons, that even here, at the edge of the cosmic abyss, something can escape. Not whole stars or planets, but something even stranger, tiny threads of energy, whispers of heat, radiation. You pause, floating between wonder and rest. The silence deepens. The black hole does not roar. It hums, and as you drift just beyond its reach, a new question begins to form in the stillness. If nothing can escape, why is it glowing? In the quiet that surrounds you now, time breathes a little slower. You are drifting through a wide ocean of darkness, scattered with points of fire. Each star you pass is a story still unfolding, pulsing gently like the heartbeat of a distant animal sleeping beneath the surface of the sea. You float silently, not quite part of this world, but not separate from it either. And then you see it. A light deeper and redder than the rest. A massive star nearing the end of its long, luminous life for millions upon millions of years. This star has burned, fusing hydrogen into helium, helium into carbon, and on, layer upon layer, like the rings inside a tree. In its core, pressure and heat have held hands tightly, keeping the star stable, perfectly balanced between gravity pulling in and heat pushing out. But now, that balance falters. The core grows tired, fuel runs low, the outward pressure weakens, and gravity, that ancient, patient force, begins to win. You watch, gently suspended in space, as the star folds inward. Not in an explosion, not yet, but in a slow, aching implosion. Imagine a cathedral ceiling collapsing under its own weight, but silently, inward, beautifully. The outer layers begin to fall, following the surrender of the center. This is not chaos. This is choreography. You can almost hear the sigh of the star, not with your ears, but with something softer, deeper. The fabric of space around it seems to tighten, like a net being drawn closed. Photons, once flung outward in wild celebration, begin to hesitate. Light, stretched thin, starts to bend. You are witnessing a collapse, not just of matter, but of light itself. This dying star doesn't go quietly. For a moment, it flares in protest. The outer shells crash inward, hitting the dense core with such force that a final, brief brilliance escapes a supernova. It's dazzling, a bright wound in the sky. For a few days, this single star will outshine an entire galaxy. But that light, too, is a farewell. At the center of the explosion, the core does not survive. It compresses under its own weight, shrinking beyond anything familiar, beyond atoms, beyond structure, past the point of resistance, and here, in the dense remains, something extraordinary begins. A black hole is born. It has no surface, no shining shell, only an edge, the event horizon, a place where light can fall in but never return. The boundary between what can be known and what cannot. You're far enough away to be safe, but close enough to feel its presence. Not as a danger, but as a gravity in your thoughts. This black hole is invisible, yet its fingerprint on space is undeniable. The light from nearby stars swirls around it, curved and stretched. It's as if space itself bows in reverence. Nothing dramatic to see, just a sudden absence, like walking into a room and realizing someone important has just left, and yet there's beauty here. You begin to understand that a black hole is not a violent thing. It is a quiet sculpture carved by gravity and time. In your imagination, you picture the star's final light, still traveling, still racing across the universe long after the star has disappeared. Perhaps one day that light will reach another planet, another thinker, another dreamer, and they, too, will wonder where it came from. This is how endings stretch beyond themselves. The space around the new black hole hums with potential, material. Left from the star dust, plasma, fragments of what was, spirals inward. It forms an accretion disk, a glowing ring of matter heating up as it nears the edge. You imagine it like water circling a drain, not being pulled, but gently surrendered. This swirling dance creates some of the brightest beacons in the cosmos. Quasars, blazars, the paradox of black holes. Their mouths are dark, but their presence can light up the sky. Still, at the center of all this motion is a stillness. You hover here, watching something that defies your everyday sense of time and space. The black hole is small in size, yet vast in gravity. Everything about it challenges what you once thought space could be, and yet it simply exists, unmoving, quiet, complete. You wonder, as scientists do, what truly lies beyond the event horizon. What happens to the matter that crosses that invisible line? Is it crushed into a single point, a singularity, a place where the rules of physics dissolve? Or is there more to know? Something new waiting in the dark? That question echoes through you, not with urgency, but with fascination. You rest in the pause between answers, because some mysteries don't need to be solved to be loved. The star is gone. The light is dimming. But in its place, a different kind of beauty has appeared, silent, invisible, and infinitely deep. You exhale, slowly, and begin to drift backward, again letting the black hole become a dark dot. In the distance, the memory of a moment that changed the shape of the sky. The universe doesn't shout its most profound truths. It whispers them, and in those whispers, you hear the tug of something more. If a black hole is the quiet consequence of collapse, then what happens at its edge, where time stretches thin and light almost escapes? There is something peculiar about the way time behaves here. You are drifting once more, weightless in a sky that has no ceiling. The black hole you observed earlier is still near, not chasing, not pulling, simply being, a quiet knot in the fabric of the cosmos. And as you hover closer to it now, just outside its reach, you begin to notice something that stirs your sense of reality. Time moves differently here. Back on Earth, you're used to the rhythm of seconds, the tick-tock of moments lining up in neat, familiar rows. Time, there is a ruler, strict and steady. But near this black hole, that ruler bends. The ticking softens. The rows become waves. You are approaching the event horizon, the boundary that wraps the black hole like a veil. It is not a wall, not a barrier. It's simply a place in space where escape becomes impossible, not by choice, but by the shape of the universe itself. Imagine space as a stretched sheet, smooth and quiet. Now place a marble in the middle. The marble sinks and the sheet curves. This is how mass bends space. A black hole is not a marble. It is a mountain, a well, a depth so steep that even light, the fastest thing in the cosmos, cannot climb back out once it falls in. But it isn't only space that bends. Time bends to dot here. Close to the horizon, your seconds are longer than the seconds of someone far away. You can't feel it. Time is loyal to your heartbeat. But if someone were watching you from a safe distance, they'd see you slow. To them, you'd move in molasses, barely shifting. Your descent toward the horizon stretched across eternity, and from your view, they would seem to race ahead. It's not an illusion. This is gravitational time dilation, one of the strangest, most beautiful truths of general relativity. Gravity pulls on time as surely as it pulls on planets. The stronger the gravity, the slower time flows. You hover, motionless to the eye, but inside, your thoughts drift like clouds. You wonder, what is it like to cross that horizon? From here, it looks no different than any other part of space. There are no signs, no flashes, nothing to warn you, and yet it is a line you cannot return from. Outside, time continues its orderly march. But here, near the edge, it begins to stretch, slow, yawn wide. You imagine yourself holding a clock in your hand. You look down, the seconds pass like normal, steady, unshaken, but someone watching from Earth would see your clock almost stop. You would appear frozen, as if time had fallen asleep on your shoulders. In truth, time has not stopped. It has simply shifted perspective. Einstein once said that time and space are threads of the same fabric. Near a black hole, those threads twist and loop, stitched into strange patterns. The straight lines of cause and effect begin to ripple. Time becomes more than a sequence. It becomes a place, a texture you can almost touch, and you, a visitor. In this curved land, feel it not as fear, but as awe. Your mind grows quiet in the presence of something so vast. You let go of needing to measure time. You stop counting. You simply exist, floating in the pause between seconds, where thought and breath become one. Somewhere beyond the horizon, matter continues to fall. Stars, gas, dust, drawn into the black hole's embrace. To them, time collapses completely. Within the singularity, if such a thing truly exists, time may end altogether. Or perhaps it transforms into something we can't yet describe. But you're still outside, still free, still wrapped in the strange comfort of this slow-motion world. As you gaze out from your perch near the event horizon, you begin to see the universe differently. Distant galaxies no longer twinkle, they smear, distorted by gravity's lens. Their light stretches, redshifts, growing softer, longer, older. The deeper you peer, the further back in time you seem to look. Light takes time to travel, after all, and the cosmos is vast. So even as time near you slows, the universe around you rushes forward. Millions of years might pass elsewhere, while only minutes touch your skin. It is a quiet dissonance, a beautiful contradiction. You begin to wonder if time can slow so deeply here. Could it ever reverse? Could something fall inward and then rise again? Could the arrow of time, usually so stubborn, bend or break or curl around on itself? You don't need an answer. You rest inside the asking. For a long moment, everything holds still. You, the black hole, the stars beyond, a cosmic breath in a lull in the rhythm of reality. Even light here hesitates, as if unsure whether to fall or flee. And then a thought whispers through your mind. If this black hole pulls everything in, could there be something that does the opposite? Something that expels? The event horizon is not a wall. It is not a place you crash against. It is a crossing, silent, smooth, undetectable. And once past, the universe loses track of you. You are still floating, close but safe. Not falling, just listening, imagining. Out here, light still reaches your eyes. Equations still try to explain. But inside, there is silence. A silence not made of absence, but of mystery. Nothing comes back across the horizon. Not light, not sound, not stories. That is what makes it a horizon. Not just a place in space, but a boundary of knowing. You hover just beyond it, and your mind tries to reach inward. But something stops you. Not fear, not danger, just the physics itself. No signal can return to tell us what it's like. No probe can send a message back. This isn't a locked room. It's a sealed dimension of experience. And yet, we wonder, you. Let your thoughts drift forward, slowly, gently, across that invisible line. If you were to fall inward, you would not notice the moment it happens. There would be no flash, no ripple. You'd pass the horizon as calmly as walking through fog. But beyond that threshold, every direction would point the same way, deeper in here. Space and time exchange roles. Outside the black hole, you choose where to go. You move through space, forward in time. But inside, there is only one path, and it leads to the singularity. Not because you are being pulled, but because space itself is tilted inward. Time itself points toward the center. You cannot stop falling, not because you are being chased, but because the future leads there, the singularity, a place not made, of matter or metal or walls. A point so dense, so compressed, that the very rules of reality begin to fray. Mass collapses into a volume that vanishes. Equations break apart. The math runs out. What happens here? We don't know. Our physics can't see that far. You drift in the warmth of unknowing. And that too is part of science. Not only answers, but elegant questions. Questions that open, not close. Some say the singularity is a dot, an endpoint, where everything that fell in is crushed beyond meaning. Others wonder if it's a door, a fold, a kind of tunnel through space-time. Maybe it isn't the end at all. Maybe it's a bend. There is a name for this wandering, a whisper shared between physicists. Wormholes. We will get there soon. But for now, you remain in the in-between, close to what cannot be seen, feeling the shape of a mystery you're not meant to solve. And still, the question floats to the surface. If we cannot know what lies within, could there be something coming out? What if, somehow, black holes were not only sinks, but seeds? If the gravity is strong enough to trap light, could it also someday release it? You feel this question stir in you like a ripple under still water. Not an answer, just a shimmer of possibility, and gently, as your thoughts drift outward, again, returning from the edge of the unknowable, a soft glow greets you in the dark, a kind of warmth, not from the black hole itself, but from something stranger, something unexpected. It is almost nothing, but not quite. A breath, not of silence, but of radiation. Even in the darkest corners of the universe, something stirs, something quiet, something faint, something warm. You return now to the black hole, not to fall in, not to fear it, but to sit beside it, like curling up beside a campfire. Only here the fire does not burn, it barely flickers, but still it glows. You watch the edges of this strange object, the event horizon, that invisible seam where time and space fold inward. You expect it to be silent, cold, utterly still, and yet there's a whisper, a breath. Something is leaving the black hole. Not fast, not loud, but real. A faint stream of energy seeps outward. It's not a burst, not a flare. It's more like a shimmer, delicate and soft, like the warmth of sunlight on your closed eyelids. You've arrived at one of the most poetic paradoxes. In science, this gentle trickle of energy is called Hawking, radiation, and it comes from a place where nothing is supposed to return. From the edge of no return, a glow escapes. But how? You close your eyes and imagine the fabric of space quivering ever so slightly, even in a vacuum, in what we often call empty space. Tiny particles dance in and out of existence. They appear as pairs, one particle, one antiparticle, like two sides of a coin flipping into reality. This is not fiction, it's quantum nature. Space itself is never truly empty. Now imagine this delicate dance happening just near the edge of the black hole. One of the pair drifts too close and slips past the horizon. The other is left behind, unable to follow, and something remarkable happens. The lone particle, now abandoned, becomes real. Not just a flicker, not just a ghost. It carries energy, energy that wasn't there before. You're witnessing the black hole lose just a little bit of itself. Piece by piece, breath by breath, it evaporates. Not quickly, not loudly, but over time, long, slow time. It grows fainter, lighter, dimmer. The black hole glows, not from its heart, but from its edge, a soft paradox. The colder it becomes, the faster it glows. The smaller it gets, the louder its whisper becomes, until, in the far-off future, even the darkest giants may fade into light. You let that thought settle, a thing made entirely of gravity, slowly undone by warmth. Stephen Hawking imagined this, not as poetry, but as physics. He looked at the clash between gravity and quantum mechanics and saw not conflict, but conversation. A kind of tug-of-war between the vast and the tiny, the curved and the uncertain. And in that conversation, he heard something few had dared to listen for. He heard the whisper of loss, that even black holes are not eternal. You breathe slowly, resting in this idea. If a black hole can vanish, then what happens to the things it once swallowed? Stars, gas, light, perhaps even information, all drawn past the horizon. Do they return in the radiation, or are they truly, permanently lost? This becomes one of the great puzzles, because in the world of quantum physics, information, the details of what something was, cannot simply vanish. It's like tearing a page from a book and tossing it to the wind. You may lose the page, but the ink, the paper, the atoms, they still exist. Somewhere, but in black holes, it seems the page is gone. Nothing returns with its story intact. And so scientists began to ask, is the information hidden in the Hawking radiation? Is it scrambled, like ash from a fire, that still contains the shape of the log, if only you knew how to read it? Or does the black hole truly erase? You hold that question gently, not to answer, but to feel the texture of wonder. Hawking radiation, though faint, begins to speak of endings. Not violent ones, but soft dissolves, a gradual release, a kind of cosmic forgiveness. What once devoured may one day disappear itself. Black holes, it turns out, are not forever, and that shifts something in you. You picture the life of a black hole now, born from collapse, surrounded by light it cannot keep, whispering away its mass, evaporating over unimaginable spans of time. And all the while, it changes the universe simply by being there. This glow, this soft unmaking, is the final chapter in the black hole's story. Or maybe not, because now a thought rises, gentle and new. If something can radiate out, could something be pushed through? Hawking radiation leaks from the outside. But what if hidden deeper, another kind of escape exists? Not a leak, but a bridge, a way through. And here you drift once more into imagination, still tethered to science, but free to wonder. If a black hole can evaporate, could its core lead somewhere unexpected? Could the singularity curve outward again? Your thoughts stretch, slow and wide, like light bending near the horizon. Some say what enters a black hole is gone. Others say it may reappear, not here, but elsewhere, somewhere on the far side of space-to-may. And that idea opens a new door. If a black hole can lead inward, could something lead outward? Could there be such a thing as an opposite? You are floating again, weightless, in the cradle of thought. The black hole behind you hums with memory, its horizon glowing faintly, quietly. But tonight, your gaze softens, your thoughts bend, not toward the black hole, but through it. There's a question lingering like starlight on the edge of sleep. What if a black hole doesn't only pull things in? What if, somehow, it leads somewhere else? Your mind wanders gently to the idea of wormholes. Not tunnels made of steel or stone, but bridges of space itself, folded, looped, imagined into being by the curvature of the cosmos. Picture a piece of paper, on one corner, a star, on the opposite corner, another, impossibly far away. Now, fold the paper until the corners touch. The journey between them vanishes into almost nothing. That fold, that imagined shortcut, is what a wormhole might be. It is not a hole in space. It is space rearranged. A hidden hallway between rooms. Einstein and his collaborator Nathan Rosen imagined this, in theory, a structure we now call the Einstein-Rosen bridge, a connection between two distant places in the universe, possibly between two different black holes, or between something and its opposite. A black hole pulls inward. A white hole, its imagined twin, would push outward. One devours, the other expels. You let that duality rock you gently, like a tide that flows both ways. One side where time falls inward, one side where time rushes out. But here's the softness in the mystery. No one has seen a wormhole. No one has touched one or flown through. Still, the math whispers that it's not impossible. The equations don't forbid it. In fact, in certain corners of general relativity, they seem to invite the idea, like the universe is curious. To dot you, drift along the edge of possibility. To exist, a wormhole would need something strange too. Hold it open. Something the universe rarely provides. Negative energy, not the kind that makes you tired, but the kind that resists gravity. A pressure that pushes outward against collapse. Some call it exotic matter, something not yet found, but not yet ruled out. Without it, a wormhole collapses too quickly to cross. A fleeting whisper, with it, perhaps. A pathway holds, you imagine, floating toward one, a silent mouth in space, its edges ringed with light. You do not fear it. You trust the universe to be what it is, mysterious, not malicious. Crossing into such a place wouldn't feel like motion. It might feel like turning a page and finding yourself on a new chapter, far from where you began. Not through distance, but through folded space. Where would you emerge? Perhaps another galaxy, perhaps another time, perhaps even another universe. A place with its own rules, its own constants, its own rhythms of light and dark. You breathe slowly, letting that question expand like the space it describes. You don't need to know. You only need to wonder. Wormholes connect not only places, but ideas. They bind curiosity to courage. They tie science to imagination, not by leaving facts behind, but by carrying them into deeper forests. Some physicists speak of wormholes as possible solutions to puzzles we've barely begun to ask. Could they explain how information escapes a black hole? Could they serve as cosmic shortcuts in the story of the universe's expansion? Or are they only symbols, beautiful metaphors for how the universe feels, interconnected, even across impossible spans? You don't have to decide. Tonight, the wormhole is a lullaby, a gentle thought that maybe, just maybe, the end of something is the beginning of something else. Even the word wormhole is soft, a hidden passage, a burrow in space-time, carved by nature's quiet hands. You picture the cosmos with its own secret tunnels, winding beneath the surface of reality like roots beneath a sleeping tree. And you are a traveler, not through one wormhole, but through wonder itself. Let your breath follow the curve. Let your thoughts fall inward, and then outward again. Could a black hole spit matter back out? Could the collapse of light give rise to an opposite moment, a cosmic exhale? You think of stars exploding. You think of galaxies colliding. You think of beginnings born from endings. And now, softly, the question lands beside you. If wormholes are bridges, what might they be bridges to? The black hole is quiet now. It hums softly behind your thoughts, like a candle left burning in another room. You drift near it, not to fall in, but to listen. Not for sound, but for meaning. The stars still swirl in the distance. Time still stretches. Space still bends. And in this calm, you find yourself holding a delicate question. If something falls into a black hole, is it truly gone? Not just the object, not just its mass or energy, but its story, the pattern of it, the arrangement of atoms, the unique way the universe once knew it. Does that story vanish forever? Physics tells you something curious. It tells you that information, the blueprint of a thing, should never be erased. Even when you burn a page, the words are not truly lost. The ash, the smoke, the heat, they carry the imprint of what once was. If you were clever enough, you could, in theory, read the story backward from the smoke. But a black hole doesn't burn. It swallows, and what it swallows, it keeps behind a veil no one can look through. So, the question becomes, does the black hole forget? You hold this thought in both hands, gently, because here is where paradox begins to bloom, like a quiet flower in the dark. Stephen Hawking once said that anything entering a black hole is lost forever. Not just physically, but informationally. The pattern is gone, the past erased. But that troubled physics deeply because, at the heart of quantum mechanics, the rule is clear. Information must be conserved. The universe is not allowed to misplace its memory, so now you find yourself floating in a quiet storm, a place where two great theories disagree. Gravity says, the black hole erases. Quantum mechanics says, the black hole must remember. And you are in the middle, listening to both whispers at once. This puzzle became known as the black hole information paradox, a riddle at the edge of understanding. For decades, physicists debated. Some believed that Hawking radiation, the faint glow escaping the black hole, might somehow carry the information back out, bit by bit. Others imagined that the information remains at the event horizon, like a shadow, never quite falling in. Still others wondered if the universe keeps a copy somewhere, like an echo stored in the fabric of space. You breathe slowly. You do not need to solve it. You only need to sit with the mystery. And so, you wander into thought experiments, gentle stories of science, crafted not to answer but to illuminate. You visit the no-hair theorem, the idea that black holes are defined by just a few simple things: fangs, charge, spin. No details, no texture, no hair. But if that's true, how can all the complex things that fall in stars, comets, light, time, be remembered? Could the information be woven into the Hawking radiation, like steam rising from a teacup, holding the memory of the leaves inside? Or is the horizon itself a kind of recording surface, a place where information stays stretched thin across the edge? Some physicists imagined the black hole as a hologram, not erasing but encoding, like a shadow puppet, flat but full of shape. Others reached for the idea of black hole complementarity, the notion that two different descriptions might both be true, depending on where you stand. From outside, you see the information stay at the horizon. From inside, you fall with it into the singularity. But you, tonight, are not falling. You are floating beside. You are watching ideas dance in the darkness, like fireflies above still water. In this place of deep questions, your mind slows. You do not need to rush toward a conclusion. Sometimes the universe offers riddles not to be solved, but to be lived with. And as you breathe, something simple glows inside you. Perhaps black holes don't forget. Perhaps they remember everything just in a way we don't yet understand. Like dreams remembered only by the body, not the mind. You think of yourself, your own memories, how they linger in muscle, in rhythm, in scent. The universe too may remember through motion, through the patterns it continues to make. And if information never truly disappears, then perhaps no moment is ever lost, not even the ones swallowed by darkness. The paradox remains, gently unsolved, but in its center is a heartbeat, soft, steady, quiet, a pulse of knowing that the universe is not careless with its past. And just as this thought begins to settle, another rises beside it, like a companion in the quiet. If black holes, remember, could they also transform? You settle softly into the silence left by the last question, the riddle of memory, the heartbeat of information. And now a new thought begins to stir, light and curious, like a gentle breeze teasing the edges of a darkened forest. What if black holes are only half the story? If black holes pull everything inward, devouring light, matter, time, then perhaps there is something that does the opposite. Something that breathes outward, that scatters rather than swallows. You cradle this idea quietly. It feels like holding a smooth, cool stone, worn soft by rivers of thought. This other is called a white hole, not a hole that pulls you down into shadow, but a hole that pushes you out. A place where nothing enters, only flows away. A cosmic fountain, a reverse shadow. White holes are a kind of mirror, the imagined twin of black holes, but with a breath that goes outward instead of inward. Imagine a doorway where the wind flows out in gentle waves, carrying stardust and light, releasing energy like petals falling softly into space. It is not a creature of destruction, it is a whisper of creation. You float beside this possibility, imagining the delicate dance of these two forces. One pulls, the other pushes. One swallows, the other scatters. Could the universe hold both? Could black holes and white holes be two sides of the same cosmic coin, spinning slowly in the dark? You picture the black hole first, a vast, invisible whirlpool pulling everything inward, bending space and time until they curl like the pages of an ancient book. Then you turn your mind to the white hole, a radiant bloom opening in the fabric of space, releasing matter and light in an endless, gentle sigh. There is no evidence of white holes, yet they remain theoretical, whispered in the language of equations and dreams. But their existence is not impossible. In fact, they arise naturally from the mathematics that describe black holes. Einstein's equations suggest these twins could be connected, two ends of a cosmic tunnel, one end where everything collapses inwards, and the other where everything bursts outward. This tunnel is sometimes imagined as a wormhole, a bridge between places or even times, bending space like a ribbon folded in on itself. You feel yourself drifting through this bridge, light stretching ahead, shadows falling behind. The thought is not frightening, but soft, like sinking slowly into a warm bath. You watch stars scatter like petals across a breeze, each one a possible spark of rebirth. White holes do not capture you in their grasp. They invite you to watch, to witness, to imagine the universe as a gentle cycle where matter and energy are never lost, only transformed and shared again. You begin to sense the rhythm of this cosmic breath. Black holes inhale, pulling stories and matter inside. White holes exhale, releasing new light, new possibilities, new beginnings. It is a cycle of giving and receiving, of endings and fresh starts. You imagine what it might feel like to be carried outwards by a white hole's breath, a quiet journey of expansion and release, a slow scattering of starlight, like seeds falling on fertile ground. This idea comforts you, like the steady rise and fall of your own breath. It reminds you that even in the deepest darkness, there is movement, there is flow. Even when something ends, something else begins. You think of a white hole's light as a lullaby, soft and glowing, singing the universe back to itself again and again. And in this gentle imagining, your mind opens to the vastness of cosmic possibility, a space where endings fold into beginnings, and every breath holds a story. Yet, as you linger on this idea, a quiet question settles beside you. If white holes scatter matter and light, where do they come from? If black holes draw inward, how could their twin breath outwards? You sense the universe whispering, not answers, but invitation to stay curious, to keep exploring this dance of collapse and release. And as you drift, the edges of the thought begin to fold softly into the next question, like the slow unfolding of a night-blooming flower. What if what a black hole swallows isn't lost, but reborn, shaped anew in ways we are only beginning to glimpse? You settle deeper into your quiet space, feeling the steady rhythm of your breath echoing the universe's own pulse. Tonight your mind travels to the tiniest threads of existence, places so small that the usual rules begin to blur, like shadows fading in twilight. Here, at the edges of the very small reality is no longer solid or certain. Instead, it whispers softly in waves and possibilities, a gentle dance of might-be's and could-be's. This is the realm of quantum theory, a world where particles are also waves, where something can be many places at once, and where certainty is replaced by probability. You imagine this invisible weaving, a delicate loom where light and matter flutter, between states like fireflies in a quiet garden. But what happens when this quantum dance meets the immense pull of a black hole? This is the quiet meeting place where the universe's two great languages, gravity and quantum mechanics, try to speak to one another. You picture the black hole not as a hole at all, but as a knot, a tangle of tiny threads woven from the fabric of space, time, and information. Like an intricate tapestry, this knot holds the stories of everything it has touched, its threads twisting and looping in ways both mysterious and profound. You feel the universe humming, a quiet song, a slow stitching, pulling together the large and the small, the seen and the unseen. In this space between certainty and mystery, black holes might not be emptiness, but complexity. They are not just devouring darkness, but intricate knots of knowledge, where the tiniest quantum threads twist into cosmic patterns. Imagine, for a moment, the black holes surface the event horizon as a vast loom. Each thread of light, each particle of matter that drifts too close becomes part of the weave, its information preserved in patterns of quantum vibrations. These vibrations are not noise, but a silent song, telling a story that might last beyond the fall into shadow. You rest with this idea, letting the gentle pulse of the quantum weave calm your mind. Your thoughts slow and stretch, much like space itself does near a black hole's edge. This dance of quantum threads may hold the key to understanding what happens beyond what we can see. Maybe the secrets of black holes are not locked away forever in darkness, but are woven into the very fabric of the cosmos, a tapestry that stretches beyond time and space. This quiet work of quantum threads is both fragile and profound, like a spider's web catching the first drops of dawn. And just as you begin to feel the gentle strength of this invisible weave, your mind drifts toward the questions softly forming in the space between thoughts. If black holes are knots of quantum information, how does the universe keep its stories safe? You lie back gently, letting your body sink deeper into quiet calm, your breath a soft rhythm echoing the slow pulse of the cosmos. Tonight, your mind drifts to the subtle ways the universe remembers, not with ink or voice, but with gentle waves that ripple through the very fabric of space and time. Imagine space-time as a vast, still pond. Every event, every motion sends out ripples, waves spreading slowly outward, whispering across the cosmic surface. These ripples are called gravitational waves, and they carry with them the soft echoes of deep, distant stories. You picture a black hole, immense and silent, its immense gravity pulling and twisting space itself. When two black holes dance close, spiraling into each other, they send shivers across the pond of space-time. These shivers are the gravitational waves, faint but persistent, like lullabies that travel for billions of years before reaching your mind. You imagine listening closely as these waves wash gently over your senses. Their rhythms slow and soothing, a cosmic heartbeat echoing through the universe's vast quiet. Each wave carries a secret, a story from faraway collisions and transformations, from moments when matter and space are woven into new patterns. This memory, carried not in stone or sound but in the shape of space-time itself, invites you to think about how endings like black holes, swallowing stars, or the fading light of a distant sun are not just loss. They are also a kind of transformation, a letting go that leaves ripples behind. You feel the edges of your thoughts soften, like the gentle folding of night around a quiet room. The ripples remind you that even in endings, there is a lingering presence, a trace that stretches outward, touching everything and nothing all at once. The universe does not forget. It records with grace, weaving every goodbye into the unfolding tapestry of time. And in this gentle remembering, there is a strange comfort, the feeling that nothing truly vanishes without leaving a song. You rest with this idea, allowing the gentle waves to rock your mind, your thoughts blending with the slow, infinite hum of space-time. The hush of the cosmos becomes your lullaby, a soothing melody that carries you towards sleep's edge. Yet, beneath this calm, a question stirs, delicate and persistent. If space-time remembers, what does it mean for us? For the moments we hold dear, the people we lose, the stories that end. Is every ending also a release, a ripple sent outward to touch new shores, unseen but not unfelt? As your breath slows, and your eyes grow heavy, you carry this quiet wonder with you, wrapped in the tender rhythm of cosmic memory. The universe's soft song lingers, inviting you to rest and to dream of what lies beyond each goodbye. In this quiet, you begin to sense the unfolding next step, the whisper of a new thought drifting closer. If the universe holds memory in waves and threads, could there be a way to glimpse what has been lost, or to find something waiting to return?